there, Mr. Sutton here, bringing you the Algebra 2 7-5 Part 2 homework solutions on solving rational equations. In this one, we focus on multiplying by the LCD. For this problem, since I don't have a single term on each side, I'm not really looking to cross multiply these. I'm just going to multiply everything by the LCD. So that's going to be 2 and an x. That's everything in our denominators. So just multiplying the numerators here, and this 2 also needs to get multiplied by the 2x. So everything that is definitely a numerator or could be a numerator if I had that invisible 1 in the denominator. All right, so let's see what cancels. First fraction, the 2's are canceling. After that, it's the x's, and nothing cancels over on this other side. So we've got 3x for that first term now, plus 1 times 2 is 2. Equals 4x. And then if I just subtract 3x over to the other side, we see that x just equals 2. But now we have to double check. If I plug 2 in for x in the original, do I get 0 in any of my denominators? I do not. So that means that 2 is a good answer. To solve this rational equation, we're going to find and multiply by the LCD. So looking at our denominators, we need an x in there, and also this x minus 4. So now let me multiply all these numerators by this LCD of x parentheses x minus 4. Now that I've done this, I'm going to go through and cancel out my denominators. The first fraction, we have our x minus 4's canceling. Second fraction, it is the x's. And then for this last one, we have the x minus 4's canceling. So first fraction again, we've got 8x. After that, this 4 is getting distributed to the x minus 4, so this is a plus 4x minus 16. And over here we have 2x times x, so 2x squared. Let's get everything over to one side since this is a quadratic. So 2x squared can stay where it is, and I'll move the 8x and the 4x over there. Actually, that adds up to 12x, so let me subtract that over to the other side, and then let me add 16 over there. Now I notice that these are all divisible by 2, so let's go ahead and divide them by 2. That gives me x squared minus 6x plus 8 equals 0. And this one looks like it ought to be pretty simple to factor. Things that multiply to 8 and add up to negative 6. 1 and 8 doesn't work, but 2 and 4 does, if you have a negative for both of those. So x minus 2 and x minus 4 equals 0. Setting each of these equal to 0, we have x equals 2 and x equals 4. Now we always want to double check to make sure nothing's undefined if I plug these in the original. If I plug 2 in up here, 2 minus 4, 2, none of that's going to be 0 in the denominator, so that's fine. If I plug 4 in, however, 4 minus 4 gives me 0. So 4 is going to make the original undefined, which means we actually have to cross that off. That's an extraneous root, and only 2 is a correct answer for this. On this problem, let's go ahead and find the LCD and then multiply that by that to solve the rational equation. So I need an x minus 3 and an x minus 5. And I only need one of those x minus 5s because we only have x minus 5 to the first in either of these. So multiplying all the numerators by this LCD, it's a lot of writing, but we're gonna benefit from it on this next step because we're crossing off some denominators. So x minus 3's cancel in this first fraction. Next, it's the x minus 5's canceling there, and the x minus 5's cancel here as well. All right, let's distribute and see what's left here. So distributing in this first one, we've got x squared minus 5x plus 3x, and then 3 and negative 5 gives us negative 15. Next up, we have x being distributed, so that's going to be x squared minus 3x, and then over here we've got x plus 5 times x minus 3, so lots of FOILing going on here. So that's x squared minus 3x plus 5x minus 15. All right, we have a lot of cleanup to do over here. So let's move everything over to the left side because I've got more x squareds over there, so I want to end up with a positive x squared when the dust settles. We have an x squared plus an x squared. That's a 2x squared. We're going to be subtracting this x squared over here, so we just have a 1x squared on the left, which is really good. Now let's take a look at these x's. So we have a negative 5x and a 3x would be negative 2x. Plus the negative 3x here gives us negative 5x. And let's see here, there's a 2x over here that we're subtracting, so that would be negative 7x total. In terms of numbers, we just have this negative 15 on the left. I'm going to be adding 15 from the right side, so those actually cancel out completely, and I just have equals 0. Well, that's actually a lot easier to factor than I thought it would be with all this stuff. Sometimes you never know. So let's take an x out of those. That leaves me with x minus 7 equals 0. So we have x equals 0 and x equals 7. Now to either of these make the original undefined. If I plug in 0 or 7 to each of these, I don't get 0 in the denominator. So these both work out. For this problem, to solve this rational equation, I want to figure out the LCD. To do that, I want to first factor this denominator to see what I'm dealing with. So things that multiply to 12 and add up to negative 8. Let's see, 1 and 12 doesn't work. 2 and 6 works if they're both negative. So this becomes x minus 2 and x minus 6, which thankfully is what I have in the other fractions. Nice coincidence there. So that means my LCD is just x minus 2 and x minus 6. Alright, so multiplying everything by the LCD then, and by everything I just mean the numerators here. So in the first fraction, the x minus 6's are canceling. In the next one, it's the x minus 2's. And finally, both of the parentheses cancel in that last one, so that's good. Distributing in our first one, 1 is just being distributed to x minus 2, so that's just x minus 2. Next up, we have x being distributed, so that's going to be an x squared minus 6x. And then that all equals 4. We can leave the x squared where it is on the left side. I have an x over there and a negative 6x. That's going to become negative 5x. And then I have a negative 2 there from which I'm subtracting this 4, so that's going to be a negative 6. All right, well, looks like I can factor this. Things that multiply to negative 6 and add up to negative 5. 1 and 6 works if I have positive 1 and negative 6. So x plus 1 and x minus 6. Zeroing each of these out, we end up with x equals negative 1 and positive 6. Do those both work if I plug them back in? Well, negative 1 doesn't give me 0 in any of the denominators, so that one's actually okay. 6, however, 6 minus 6 is an issue because that gives us 0 in this first fraction. So that one actually makes this undefined and we have to lose it, which means only x equals negative 1 is an answer.